Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the common mistakes video, we flagged that beta 2 is not the constant group difference. Now, let's go a little bit deeper into that because there is a very specific visual version of this mistake that trips up even careful students. It comes down to one question, which is, what does the vertical distance between two regression lines actually measure? And for this, we're going to use the same worked example that we had for the dummy times continuous visualization case. In that particular exercise, we had the estimated model here, y equals to 1000, 50x, 200d, and then 30x times d. X being the continuous variable, which was years of education, and d being a dummy, whether you were employed or not. Okay? Based on this information, back in the worked example exercise, we figured out that the two fitted lines were the blue and the orange one, the orange one being the fitted line for the unemployed and the blue line being the fitted line for the employed people. Okay? This was done based on two lines, which were y equal to 1000 plus 50x and y 1000 200 plus 80x, okay? So let's look a little bit more carefully at the gap that is actually shown here. In the previous video, I just very quickly showed like this distance in here, and I said that the change in slope is the beta 3 equals to 330 to 30. So it's very easy to misinterpret this and to think that that specific distance that I'm showing you right there is the 30. So when students see the two lines on the graph, they look at the vertical distance between them and they might say that the distance everywhere is beta 330. Now, that is wrong because the vertical distance between the lines is not exactly the beta 3. And to make that point in that video, we had further written down the partial derivative just so that you could be very clear about like how to calculate that distance. So if we do a partial derivative of y with respect to d, that would be simply beta 2 plus beta 3x, which applied with the numbers that we have here, it's 200 plus 30x. Okay? We computed this at 2 points, if you remember. We had at x equal to 5 and then at x equal to 10. For the first case, we had that the effect was 350, and for x equal to 10, we had that this partial derivative was 500. Now, the gap, this 350, this is the gap at x equals to 5, while this 500 is literally the gap at x equals to 10. So if we look again at the graph, we very clearly pointed out that this distance right here is not the same as this distance right here because the partial derivative depends on the value of x in here. And in fact, this first arrow right here, this is this distance of 350. And the second arrow in here, that's this gap of 500 that we just computed. Now, look very carefully. None of these two gaps is really equal to 30. So what is exactly going on in here? What is the beta 3 exactly? Well, beta 3 is not the gap, remember? So beta 3 is not a gap. We very clearly said that beta 3 is a difference in slopes. And I'm going to put that in a box for you guys so that you don't forget this. Okay, so not the gap itself is the difference in slope, which means that when you are looking at the unemployed people, their slope is exactly 50. And when you're looking at the employed people, the slope is actually the 80, and this difference is the 30 that we're talking about. Now, beta 3 lives in the slope, not the vertical distance between the lines. Think of it this way. Beta 3 tells you how fast the gap widens as x increases. Okay? Not how wide the gap is at any particular point. Okay? Now, the next thing to do is like, well, let's decompose this gap very visually. Okay? Because this gap actually has two components, as we can see here with this added dashed orange line. When I introduced you to this dashed orange line, I told you, well, if there was no partial effect or like combined effect of this x and d, then your fitted line for the employed people should have literally been the parallel shift up of the fitted line for the unemployed people. However, that is not the case because now we know that there is also this change in the slope. So that means that I can decompose the gap visually into, so decompose into beta 2 being equal to 200. Okay, so this is the fixed part of the gap. Okay, this is literally due to the intercept shift. Okay, so intercept shift due to the dummy. Okay, and keep in mind, same for any value of x. Okay, so if we go back to this graph that we have, this distance is right here. So this distance, or this distance right here, these are all the same. Okay, and this difference is everywhere 200 because the shift in the intercept that happened in here was exactly 200, going from 1000 to 1200. Okay, the second component of this decomposition is the beta 3 times x, which in our case is 30x, and as you can see, we can't give a fixed number to it because this very clearly depends on the value of x. Okay, so this means that this is the growing part of the gap. Okay, and it increases by 30 for every additional unit of x. Okay, so this is where that beta 3 lives. A useful way to see this is, imagine that you're basically drawing a third line, okay, through the employed intercept, but with the unemployed slope of 50. So the distance from the unemployed line to this imaginary line would have always been this beta 2 equal to 200. Now, the distance from this imaginary line to the employed line is the beta 3x. So this means that in this 350 gap that we had right here, so this is our 350 gap, the green line, the fixed part is the 200 in here. So what happens to the rest of it? The rest of it, which is this gap right here, that is literally your 30 times x. The x at this particular point was 5, so it's 30 times 5, which should be 150. And look, now if I actually add up 150 to the 200 fixed, this gives me exactly my first answer, that this gap in here was the 350. Okay? So let's do the same interpretation, the same decomposition when we had x equal to 10. So this green distance in here, it's decomposed as 200, this distance right here, and then whatever is left in here, this distance. Now this distance, I know that it's 30 times x, and x is 10 in this case, so this should be a 300. And look, the 300 plus the 200 in here make exactly the 500 distance that was in here, okay? Also notice, this particular distance in here, the blue arrow, and this particular distance in here, although they depend on 30, they are not 30, okay? They evolve with a 30. So it's 30 times 5 and then 30 times 10, okay? So 3 things to keep separate. Beta 2 is an intercept shift, okay? This means this is literally the gap when x is equal to 0. Beta 3 is the slope difference. Okay, so the rate of change of the gap. And the beta 2 plus beta 3x, that is the total gap at any value of x. Okay? And as usual, this is an important result you need to keep in mind, so I'm going to put this in a box for you so you remember that. So beta 3 is never the actual gap, it's the rate at which the gap grows. Now, why is this so important? If you misread the beta 3 as the gap, you will basically understate the group differences, especially for high values of x, or you might overstate it for low values of x, or you will entirely miss the fact that the gap is not constant at all, okay? Keep in mind, especially for students who might be doing a dissertation and are using a difference in difference model or are using an interaction model, if you report beta 3 as the difference between the groups, your interpretation is going to be incomplete. So you need to make sure that you report beta 2 plus beta 3x at meaningful values of x, okay? Because as you can see here, beta 2 plus beta 3x, that's the total gap at any value of x. So the vertical distance between 2 regression lines is beta 2 plus beta 3x, not beta 3 alone. Now that we've cleared up this misconception, we're ready to move on into the last bit of this mini-series, which is log models with interactions. So stay tuned, and I'll see you in the next video.